Okay, so this is a review of writing chemical formulas and naming compounds. And I'm just going to go through the basic rules and give you some examples, and hopefully this will fill in the blanks where you're having some troubles. So let's start with ionic compounds. So you know that ionic compounds are between a metal and a nonmetal. And we're going to look at binary compounds first. So when we talk about binary compounds, we are talking about two different elements only. So in this case, it would simply be the metal and the nonmetal. So to name an ionic compound, you simply, and if it's a binary compound, you name the metal, and then name the nonmetal and change the ending to IDE. So a couple of examples would be KCl. So here's our nonmetal, so we're just going to name it potassium, and then we take the nonmetal, which is chlorine, and change the ending to chloride. Another one would be Na2S. So we name the metal, which is sodium, and we name the nonmetal, which is sulfur, and change the ending to sulfide. Okay, let's talk about ternary compounds. Ternary compounds have 3 or more different elements. And usually when you have a ternary compound, there is a polyatomic ion present. So we know that we're going to be using table E. There's a couple ways that this can appear. You can have a metal and a polyatomic. So in which case you're just going to name the metal, and name the polyatomic. There's no changes made to either part of the name, as there is with a binary compound. So for example, I could have MgNO3 2. So here's my metal. I'm going to name it. It's magnesium. And then I'm going to go to table E and look up NO3, and I see that it's nitrate. So this is magnesium nitrate. Now, there is a situation where you will change the end, but I'll do that one last. Another situation that you might have is 2 polyatomics. And you simply just name them. So an example might be NH4, NO3. Here's my first polyatomic, and here's my second polyatomic. So I look up NH4 in table E, and it says ammonium. And NO3 is nitrate. So this is ammonium nitrate. I'm just going to go back and underline these different subcategories. Here we go. Okay. We might have a polyatomic, and a nonmetal. So in this case, we're going to name the polyatomic, and then name the nonmetal, and changing the ending to IDE. So an example of this might be NH4Cl. Here's our poly, so we name that ammonium. And then that's chlorine, so we're going to change that to chloride. Okay, so that's about it for ionic compounds. We're going to do all the naming first, and then I'll go through the writing. So let's talk about covalent compounds now. Please remember that another word, when we talk about covalent compounds, this is also synonymous with molecular. We're talking about the same thing, okay? All nonmetals. And when we're naming nonmetals, we need to use prefixes. And the prefixes that you need to use are 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. I could do 7, 8, 9, 10, but they're not the most popular. 7 is hepta, 8 is octa, 9 is nona, 10 is deca. There are a couple of rules. 1, if the first element has only 1, then no prefix is necessary. And this is just the first element. The second element has 1, then we need to use 1. Just the first element. Second, if there are 2 vowels next to each other, drop the last vowel on the prefix. And I'll give you an example of this. So if I have N2O4, I have 2 nitrogen, so this is going to be dinitrogen. So it tells me I have 2 nitrogens and 4 oxygens. So this would be tetra for 4, and then oxide. And we have 2 vowels here. We can't say tetraoxide. So I'm going to get rid of the A and make it tetroxide. So let's do a couple of examples. Okay, here's 4 examples. So we have 1P, so we don't need a prefix, so we're just going to write phosphorus. And we have 3 chlorines, so 3 is tri, and this would be chloride. SF6, S, we have 1, so it's going to be sulfur. And 6 is hexa. and that would be fluoride. CO is carbon, or C is carbon, and we have one O, so that's going to be it would be monooxide, but we can't have two O's, so we're going to drop one of the O's and make it monoxide. And the last one, we have nitrogen, and we have two oxygens, so it's going to be dioxide. Okay, let's talk about, well, it's not just transition elements. Transition elements plus a few extra. So transition elements are in groups 3 through 12, but popular ones in this group are also tin and Fe, tin and lead, which fall outside of the transition elements. But we're really talking about elements with more than one positive oxidation state. So if you look at tin on your reference table, it tells you it has a +2 and a +4. And if you look at PB, it says it's got a +2 and a +4. And Fe is +2 and +3, and copper is +1 and +2. So anytime you're going to have an element with more than one positive oxidation state, we need to use Roman numerals. To tell us which state was used. For example, if I have CuO, you know that O is -2, therefore copper had to be +2. So when I write the name of this, I have to write copper, Roman numeral 2, oxide. If I write Fe2O3, I know that this 2 came from here and this 3 came from here, because when we drop and cross, we go up and over. So this would be iron, Roman numeral 3, oxide. If I said if I looked at this, NiCl2, you know chlorine's -1. Nickel had to be +2, but nickel has a +2 or a +3 oxidation state. So this is nickel, Roman numeral 2, chloride. So there's some example of transition elements with more than one positive oxidation state where you need to use a Roman numeral. So 1 is obviously just 1, 2 is 2, 3 is 3, 4, IV, 5 is just a V, 6 is VI, and you're not probably going to get more than that. Alright, so now I'm going to go right into how do we write chemical formulas from the names. So I'm going to go in reverse order. Since I'm working with transition elements right now, I'm going to start with them. So let's say I have the name manganese 2 oxide. Manganese, Roman numeral 2 oxide. And I need to write the formula. Please do not confuse manganese with magnesium. Manganese is Mn and magnesium is Mg. So we're going to write Mn. This Roman numeral means that we are using the +2 oxidation state for manganese. And oxygen is O, and it's got a -2 charge. So this is +2 -2, it's 1 to 1. So my formula is simply MnO. Let's look at palladium, Roman numeral 4. Bromide. Well, first of all, you need to know what palladium is. So if you're not sure, you're going to go to table S. If you look up element 46, you'll see that palladium is Pd. This means that we used a +4 for palladium. And you know that bromine is -1. So what you're going to do now to write the formula, you can simply just drop and cross, not the charges, but the numbers. 4, 1. But we never write the 1, so the formula is going to be Pd, not Pb, Pd. Pd Br4. Okay, let's do a couple of more. How about lead 2 chloride? Lead, Roman numeral 2, chloride. This 2 is for the lead. Lead is Pb, so that's a +2. Chlorine is -1. So when we drop and cross on this, it's PbCl2 because we don't write the 1. Let's look at chromium. CHR, sorry. Chromium. Roman numeral 6, oxide. I picked this for a reason. So this is going to be +6. So Cr is +6 and O is -2. So when you drop and cross on this, you get Cr2O6. However, this is not the final formula, because this can be reduced. 2 goes into 2 once, and 2 goes into 6 3 times. So the real formula that you'd have to come up with is CrO3, because we want the most reduced state when we write a formula. Alright, let's move to, since we're talking about ionic compounds here, let's name some ionic compounds. So I'm just going to pull some out. Well, not name, you're going to write the formulas. So let's write formulas for zinc oxide, strontium sulfide, and aluminum fluoride. So you're simply going to write down the symbol Zn, and it has a charge of +2, and O is -2. So this is 1 to 1, so our formula is ZnO. Strontium is Sr, it's +2. Sulfur is S -2, it's 1 to 1, so SRS. Aluminum is +3, F is -1. Well, I got to drop and cross. So this becomes AlF3. Now, let's talk about some ternary compounds. For ternary compounds, I might have manganese. Go back to that again. Manganese 2-phosphate. So manganese is Mn. It's telling me that I'm using the +2. Phosphate is a polyatomic ion. If it ends in ate or ite, it's probably on the polyatomic ion chart. There are a few exceptions, like peroxide. Phosphate is PO4, and it tells me in table E that it's a -3 charge. So remember, I've got to drop and cross. So this becomes Mn3PO4, and we have to put this in parentheses because there's two of them. Okay, let's do a couple of more. Potassium carbonate. So this 8 tells us it's a polyatomic. K is +1. We look up carbonate in table E, we see it's CO3 -2. So when we drop and cross, we get K2CO3. We'll do one more. How about, we'll do one that's a little tricky. Let's do tin, Roman numeral 4, selenide. So tin is Sn. This is telling us to use the +4. Selenide is selenium, which is Se, which is -2. So we've got a +4 and a -2, and we drop and cross, and we're going to get Sn2 Se4. But this is not reduced. 2 goes into 2 once, and 2 goes into 4 twice. So our final formula is SnSe2. Okay, the last thing that I want to talk about is the covalent compounds. We named covalent compounds. Now we need to write some out. So let me grab a couple of those. And so how about boron trichloride? Here you don't have to look up oxidation numbers, you just have to follow the words. So boron is B, trichloride, so 3 chlorines, BCl3. Di-arsenic pentoxide. So you need to know what arsenic is. Arsenic is number 33, and it's As. So we have 2 arsenic, so it's As2. Pent is 5. I'm just going to write these down here, and it's oxygen, so it's O5. And let's see, carbon disulfide. So carbon is just 1, and we got 2 on the sulfur, so CS2. And we'll do one more. How about P2O5? Oh, well, let's name it since I was going that way. P2O5. I think we did this one before. We'll just get rid of that. I'll find something else. How about sulfur dioxide? So you've got sulfur is S and di is 2 and oxygen, so SO2. Okay, that is the best I can do on a review of naming compounds and writing formulas. I hope that helps.